U.S.-affiliated Pacific Islands, we've been talking about them just shows you where they are. And you've got basically the U.S. territories and Commonwealth of American Samoa down in the southeast, CNMI and Guam up in the northwest, and then the freely associated states running east to west of the Republic of the Marshall Islands, the RMI, the Federated States of Micronesia, the FSM, and Palau. And on these, for today, I'm going to concentrate on a few key islands within them that are the larger islands for which we actually have data on drought. What is drought? There's no set definition of drought. Palmer in 1965 probably did as good as we can. It's a prolonged and abnormal moisture deficiency. But when I started slicing drought through the region, I looked at it in 5 different levels. Meteorological, which is how most people think about it. Hydrological, how it affects groundwater and stream flow. Ecological, how it acts on ecosystems. Agricultural, obvious, hits crops. And finally, the socioeconomic aggregate impacts of all of these as they affect communities. And so that's how the report was structured. You know, the atmosphere has gotten steadily warmer since 1880. We got told about this late yesterday. We just had the warmest 3 years on record. Maybe we'll be lucky this year and it will only be the 4th warmest year ever recorded, which at least would be some sort of improvement. And a warmer atmosphere holds more water, as people in Houston found out when they got 50 inches of rain in 6 days with Hurricane Harvey last August. However, we can beat that here in Hawaii because we did it in 24 hours at Waipa. So we got 49.69, which shows Texas isn't bigger than us on everything. So go big or go home. The point, though, is such events may become more common in the future because a warmer atmosphere holds more water. So we really don't need to worry about drought, right? Because atmosphere, we got more water. Well, okay. Pao-Shin ran for me in my report using the CMIP-5 model ensemble. These are CMIP-5 outputs. Some projections of average daily temperature through 2099. And don't memorize all these. There's lots of numbers and it's small, but once again, this is downloadable. The point is, it's going to get warmer, projected by several degrees C by the time you get to the end of the century. In fact, he originally gave me the outputs and they looked really small and I go, what's this? He goes, well, that's Kelvin, because that's what atmospheric people use. And I'm like, I don't do degrees Kelvin. But anyway, these are converted to centigrade. And precipitation, similarly, you're going to tick up a little bit, and these are in millimeters per day on average. So you may pick up a couple millimeters per day. So things are good. It's going to get warmer. It's going to get wetter. What's not to like? Well, a warmer, wetter atmosphere does not mean the drought doesn't occur in the future. If you have higher air temperatures coupled with increased precipitation, you simply drive higher evapotranspiration, which means, as they're finding out in the western United States, you can pick up more moisture, but if it gets hotter, your fire danger increases even though you're in a wetter regime. So vegetation can end up drought stressed. In addition, precipitation in the US API is temporally episodic, which means it doesn't always come the same way in the same time every year. So you have pronounced wet and dry seasons, for instance, in the Marianas every year. You have interdecadal cycles due to ENSO, and you have intradecadal cycles due to ENSO and interdecadal cycles due to the PDO. This is just a very rough diagram of ENSO cycles since 1950, with the tan bars simply indicating times when drought occurred in the region. And the bars are not supposed to indicate either how big or long the drought was, they're just showing you when droughts were recorded to have occurred, because our data is not that great. But you'll notice something. All droughts correlate with ENSO events, El Niños, but not all El Niños correlate with droughts. Okay, that's an important take-home message. So we can predict that when we are going into an El Niño, there's a possibility of drought, but it doesn't guarantee it. This is a cave drip water analysis from Guam, and it simply shows how much groundwater was coming through the limestone and into the caves. It was an isotopic analysis by Parton and all. But what I noticed was that you could see that it partitioned out into some periods where you were getting more or less precipitation, and those roughly lined up with the Pacific decadal oscillation. So you can see that it gets wetter in the cool phases and it gets drier in the warm phases, roughly. And it's obviously not a decadal oscillation, it's a multi-decadal oscillation. But we're realizing that the PDO drives quite a lot of stuff out here with ENSO running around inside the PDO cycles, okay, like little teeth on a saw. So you have 2 distinct climate regimes in the US API. This is the equator, basically. You have the Western North Pacific subregion, where it's influenced by the East Asian monsoon, the Western North Pacific monsoon, and this is Guam, CMI, Palau, basically all of Micronesia. Then you have the South Pacific subregion with American Samoa, and that's largely driven by the South Pacific convergence zone, with some influence from the Australian northwest monsoon. Essentially, the jurisdictions north of the equator are far more prone to drought during El Nino events than are the jurisdictions to the south. So American Samoa can pick up droughts, but it doesn't happen nearly as frequently or chronically as you see north of the equator. Okay, going through jurisdiction by jurisdiction. I'm showing you these are not, the precipitation is average rain per year, not what would trigger drought, but essentially just to show you how wet these places are or aren't, and all of them are fairly wet. We have a good rainfall record, and also how long we have rainfall records since. And like in Guam, it's since 1906, but we had droughts in 65, 73, 77, 83, 87, 98, 2016. If you average it out, about once every 10 years. Northern Guam is a limestone groundwater sector, and southern Guam is a volcanic surface water sector, and so drought affects, in particular, surface discharge in southern Guam. As in a lot of jurisdictions, the ecological manifestations are an increase in wildland fire, and just for Guam, we actually have good statistics. You had 1,944 ignitions in 98 versus 730 on average, so you more than double your ignitions in a drought year. Agricultural drought in 83, where we had good statistics, they lost 90% of their taro production, 60% of their banana and avocado. So if that puts it in food security context. And water supplies were not really affected on Guam. It's a good aquifer in the north, but population and demand are both growing, so stay tuned. Saipan has a really not so great rainfall record, lots of gaps and hard to put together. In terms of hydrology, in the 82 drought, spring discharges dropped by 31%. In 98, the freshwater lenses decreased by 25. Like on Guam, you had a lot of fire. Agricultural drought hardly hit them. They don't have much of a sector there. 90% of their water comes from wells. Therefore, if you have drops in water level or increased chlorination from seawater influence, then drought puts their water supply at risk on Saipan. So they actually have some real vulnerabilities there. Palau is interesting. It gets tons of rain. It gets over 3,700 millimeters a year. But strangely enough, if you get down in about the 1,000 millimeter range or in the 1,500 millimeter range, you start to get into drought because Palau is incredibly impermeable on Babbledab due to the bauxite clays. So you have a 77 to 91% runoff rate, which means almost all the rain that falls goes in the ocean. You don't have aquifers, so you've got to store it as reservoir or catchment, and once that runs out, you don't really have springs. Agricultural drought in 82, 83, they lost 80 to 95% of taro and cassava. And as noted, the municipal water systems are extremely vulnerable due to their reliance on storage. Yap. Another nice wet place. Good long-term rainfall records due to the German colonization, and so linked droughts in some of the years previously mentioned for Guam. We don't have very good stream flow data, essentially only 68 to 92, and the green schist geology creates intermittent flows in any case, so the streams often go dry naturally. They have a good fire control program on Yap and good statistics, so 22% of the main islands of Yap burned in 83 and 98 droughts. So that gives you an idea of the scale of wildland fire. 1 out of every 5 hectares would burn. No real good data from Yap on the ag sector, and they actually have done a good job on their water supply, so it's not a problem. Chuk, same story on meteorological. I'm not going to repeat this for every place. There are some facts. The Waikan River ran at only 8.4% of its normal flow in 83, so clearly a surface water problem. They lost a lot of springs in that time. Wildland fire has caused a spread of invasive grass species, which promote more fire in the next drought. They have very poor municipal water systems, so as such, they are quite vulnerable with those small islands to drought. Pohnpei, super wet place, 7,600 millimeters a year. It wins. And they've got good long-term rainfall records, once again, due to the Germans. They only had 12% of their normal rainfall in 1983, in the first half of 83. Badly fragmented stream flow data, but we do know that essentially we had only at about 5% of average during early 83. So there were some obvious effects to that. Strangely enough, although this is a very wet place, you can burn it if it gets dry enough. 50% of the upland forest burned in 83, 20% in 98. So even in a place that gets 300 inches a year, it's possible to burn the forest. They have good municipal water systems, and we don't have good agricultural data. Koshrai, once again, this is another wet place, very much like Pohnpei. Had ENSO-linked droughts. Once again, 83, 98, and 2016, as you're seeing, are those were the big droughts that we've actually got a handle on. They only had 12% of their mean rainfall in early 83. That was the best documented of all these droughts. We don't have good stream flow data. In fact, we don't have a lot of good data from Koshrai, but essentially, just like Pohnpei, in 83, their stream discharges dropped to about 4 to 7% of normal. So just basically trickles in what's normally a very wet place. Marshall Islands probably has suffered the most of any jurisdiction from drought. The atolls become drier as one moves north and west. They had, significant droughts in 65, 70, 77, 83, 2016, all ENSO correlated. The drought recurrence interval is about 10 to 15 years, and we've seen a steady drying trend over the last century. Drought is starting to become actually almost chronic rather than episodic in the northern and western portion of the RMI. So in addition to all the sea level rise and wave-driven inundation problems, they have a drought problem, and what may eventually drive some people off these atolls is not sea level, but lack of water. They had significant agricultural hits in the 83 you could see that the coconut production just fell in, and it took years to grow more trees before it came back up. So coconuts, especially on the atolls, seem to really get hit in drought. And pit taro cultivation in some points is all but abandoned because you simply have had saline intrusion into the groundwater that would support the pit taro. And you've had many of these places socioeconomically have had severe water restrictions, 83, 98, 2016. So the social impacts have been very pronounced for the atolls in particular in the RMI. So this is going to be your real problem child jurisdiction initially moving forward in terms of drought. And finally, American Samoa, another super wet place. We only have a 50-year rainfall record on Tutuila, but Upolu, thanks to the British, we have a 128-year daily precipitation record, the longest in the Pacific because of that reporting station at Apia. It's fantastic. There was only 49% of their average annual rainfall in 98, and that was combined with record high temperatures. Remember what I said about evapotranspiration. So that put a lot of stress on the system, but it's uncommon. So American Samoa in general does not have a wet or dry side of the island, doesn't have a pronounced dry season. There were some losses of coconut production during the 98 drought, and they did have water rationing in 74 and 83, but they fixed up their infrastructure, and we didn't repeat that in 98 or 2016. So, in summary, meteorological drought. We have data for about 65 to 100 years in all the jurisdictions, but it's not always super great data, and it wasn't always taken at exactly the same stations. As it is, though, it's sufficient to assess a recurrence interval, which is approximately 10 years across most of the jurisdictions, except in the RMI, where it's becoming a bit more frequent. They clearly, drought episodes correlate with El Nino, but not all El Nino correlates with drought. Hydrologically, a lot of the high islands, not just Palau, are relatively impermeable. Runoff ratios exceed 50%, so a lot of the rain that falls goes straight in the ocean and lets you catch it. As such, both high islands and particularly the atolls rely on rain-fed reservoirs and catchments, and once those run out, you've got a vulnerability. Ecological drought exacerbates wildland fire. I mean, there's really no real natural ignition sources except lava in the Pacific, and that's mostly here. So these are all anthropogenic, and so anthropogenic ignitions are fueling, fires in anthropogenic grasslands, which gradually expand due to fire. And this affects your forest cover, your water retention in your catchments, and biodiversity. Obviously, drought has impacts to agricultural production. Coconuts seem to get hit pretty bad. Pit taro gets hit pretty bad, but there's a wide range of other crops for which there's some fragmentary data. And finally, socioeconomically, as noted, the atolls are more vulnerable. Therefore, if you have a lot of atolls, like FSM or RMI, you're likely to face more socioeconomic problems from drought sooner. Finally, the challenges. Drought has a long return interval, thus it's difficult to plan for it, because how do you build and maintain capacity for an event that may not occur for 15 or even 20 years, but then when it does, has a large impact. So it's a low frequency, high impact event. And you have to think about that in terms of the adaptation at every level, including public health. There are no simple solutions because you really don't have good options for banking water on atolls, or like at Babeldaw and Palau, for islands with really high runoff ratios, right? I mean, you've either got it or you don't, and once it's gone, you don't have an easy way of putting it back in. Reverse osmosis is very expensive and energy intensive. You can't just keep hauling around reverse osmosis units on barges to everybody. The other problem we have is our instrumentation networks have been steadily lost since the 1980s. GS used to do all this for us. And that's why the 82-83 drought is so well studied. Once the freely associated states became independent, it was their job to pick this up. They didn't put money into it. Those networks largely collapsed. In addition, at the federal level, USGS has had its budget progressively pruned back. So even in the US affiliate, the US possessions, what's happening is we just are losing precipitation and streamflow gauges right and left. So we have much less data than we had 30 years ago on which to either objectively assess the onset of drought or to judge its relative severity in the context of previous droughts. And this is because no one wants to pay for monitoring. Everybody wants to give you a research grant and say, here, we'll go on a date. And then they dump you, and what happens is no one wants to get married and actually have the commitment to pay for a monitoring network. And this is a chronic problem. And they say, well, you don't have to measure it on the deck, just use NEXRAD or satellite irradiance. And no, those don't substitute for in situ gauging. They've got a lot of issues, and one overestimates and one underestimates rainfall. Although they are useful for trying to figure out what's happening over the ocean where we can't necessarily put in gauges. So if you want to know more, I know I went through a ton of stuff really fast. This is the publication. You can download it there, or I've got PDF copies that I can give you off my computer. Thanks.